So good afternoon, student. You see, today in my last class I had told you about the friction. Now today I am going to tell you about the work power energy. So in my previous class I had told you what is friction, in what direction friction acts, why does friction act, how much does the friction act, what will be the amount of friction. I told you about each and everything in detail. Now let's start the new topic, that is the work power energy. Work power energy. So you see, first of all I define the work. So for the definition of work, you need to know a trigonometric term also. The work is defined as what? If there is a block and we apply a force F on it along this direction, there might be other forces also acting on it, but I'm marking one of the force F acting on it, and the displacement of the block is D along this direction. The angle between the displacement and the force is what? Theta. So you see, first of all, make this point clear that, as I told you, what you might be feeling, force is along a different direction, displacement is along a different direction. So how can it happen? How can it happen? So you'll see, just for a moment, I'm coming back, just a moment. You see, so like if you feel that force is in a different direction, how can displacement be along a different direction? It's not that. As I told you, there might be some other forces acting on the body, and there could be number of forces acting on the body. So you know this fact very well, that if number of forces are acting on the body along the different direction, eventually body will be displaced along one specific direction. It's not that number of forces are acting on the body along different directions. So body will start moving in all the directions. When you apply forces on the body of different magnitudes in the different directions, eventually the displacement of the body will be in a specific direction. So this is what is happening here, and what I'm telling you is, I'm telling you one of the force out of all those forces which were acting on the body, one of the force is what? F. F is what? F is not the only force acting on it. F is one of the force. Now what I'm telling you is that what is the work done by this force F? Work done by this force F will be equal to force F into D into cos of theta. F into D into cos of theta, this is the definition of work. Means if, as I said, there are other forces also. Suppose there is a force F1, this is a force F2. Now in this way, the work done by force F1, because the displacement is D. As I told you right now, there are so many forces acting on the body. Under the influence of all the forces, body got displaced by D in a specific direction. Then the work done by the force F will be F into D into cos of theta. Work done by the force F1 will be, this complete angle is alpha, angle from the direction of displacement, and F1 is what? Alpha. Angle between the displacement and the F2 is beta. Then work done by the force F1 will be F1 into D into cos of alpha. Work done by the force F2 will be W2, that is F2 into D into cos of beta. So that means what you have to do, when they ask you to calculate the work done by a force, in that case, consider that force into what? Total displacement of the body, into what? Cos of angle. Cos of angle between the force and the displacement, you'll get the work done. And make one more thing clear from here, that because see, cos theta, this could be positive or negative. It could be positive or negative. Maybe you might be knowing that if angle between the force, if theta is, cos theta is what? It's positive for theta between 90 and 0. Between 90 and 0, it's what? Positive. In cos theta is what? It's negative. Negative when theta is less than what? 180 degree, but greater than what? 90 degree. Is that clear? There are other angles also. The angle could be more than 180 also. You have to remember it like this. See, this is these are 3 quadrants. So up to this it is 90 degree angle. Up to this point it is 180 degree angle. 90 degree angle. Up to this point it is what? 270 degree angle. 270 degree angle. Up to this point it is what? It is 360 degree angle. Up to this point it is what? It is 370 degree angle. So what you have to see that if the theta is in this quadrant or is in this quadrant, then only cos theta is negative. Means theta is between 0 and 90, then cos theta is positive. Theta is between 270 degree and 360 degree, then also it is positive. And if theta is in this quadrant between 90 and 180, it is negative. Cos theta is negative. Between 180 and 270 degree also, cos theta is what? Negative. Though in the 9th class you need not to worry about this much about this. Generally the angle that they will give you is what? It will be either between 0 to 90 or it will be between 90 to 180. So but you have to remember that cos theta is negative in this part and cos theta is what? Positive in this part. The important thing becomes what? Important thing becomes this, that work done by a force on a body could be positive or it could be negative. It could be positive as well as it could be negative. So see here further in my class today itself I'll tell you more about it, but get to know one thing, that what is the meaning of work done by a force which is positive. When some force does positive work on a body, what is its meaning? Or when a body or when a force does negative work on a body, what is its meaning? Basically see, work is a form of energy. What we say, if someone has capacity to do work, they have got the energy. If someone has a capacity to do work, they have got the energy. That means what? If some force does positive work on a body, it's giving that much of energy to the body. If some force does positive work on a body, that force is giving that much of energy to the body. And if some force does negative work on the body, it's giving that much of negative energy to the body. So what is the meaning of giving negative energy? How can the energy be negative? How can be the energy? This can be negative energy. You see, negative energy means what? Withdrawing energy from that body. Suppose initially body has got 100 joule energy. The unit of work is what? Unit of work is joule. It is what? Joule. So 1 joule means what? 1 joule means force of 1 Newton acting on a body into displacement of 1 meter in the direction of force. So in the direction of force means what? Cos of 0. Now see, cos of 0 is what? 1. Cos of 0 is what? 1. So 1 into 1 into 1, that is what? 1. So that means 1 joule work is done when a 1 Newton force acts on a body and that displaces the body 1 meter in the direction of force. Then we will say that the work done is what? 1 joule. So 1 joule becomes a unit of work, and this is what? It is the MKS or SI unit. It is what? MKS or SI unit. So because this is the MKS or the SI unit, the CDS unit of the work is what? This is a bigger unit. CDS unit of work is CGS unit of work is arg. Here's what? Arg. And 1 arg is equal to 10 to the power minus 7 joules. So arg is relatively very small unit. 1 arg equals to what? 10 to the power minus 7 joules. There's a CGS unit. CGS MKS means what? MKS system of unit is that in which length is measured in meter, mass is measured in kg, and time is measured in second. And CGS unit means what? in which length is taken in centimeter, mass is taken in grams, and the time is measured in what? Seconds. So this is about the basic thing about the work, that how will you calculate the work done by a force and what is the unit of work. Then I told you, if some force does positive work on a body, it means if work done is, say, suppose 100 joules positive, that means 100 joule energy has been given to the body. And if some force does negative work on a body, suppose force does minus 50 joules of work, it means that force withdraws 50 joules of energy from that body. So if the initial energy of the body would have been 100 joules, and if 50 joules of negative work is done on it, its final energy will become what? It will become 50 joules. Because 100 joule was the initial energy, 50 joules of negative work has been done, that means 50 joules of energy has been withdrawn from the body, so the final energy of the body becomes what? It becomes 50 joules. It is like that. Is this clear? Now, so this is about the work. Now, in some cases, I tell you how to calculate I give the examples, how to calculate the work here. So, you see, suppose there is a block of mass m kg. By means of a string, someone is pulling the block upwards. Someone is pulling the block upwards. External agent is pulling the block upwards by means of a string with acceleration g/4. So by means of a string, some external agent is pulling the block upwards with an acceleration g/4. With an acceleration what? G/4. Now see, the calculate work done on the body by the external agent. Second, gravity. Third, net work done. Third, what? Net work done when displacement of the body is, now I write further here, when displacement of the body is d downwards. I slightly correct the question. External agent is pulling the block upwards by means of a string such that it is accelerating downwards with g/4. So you see, first of all, when you see the question, you might be surprised that external agent is pulling the string upwards, but the body is accelerating downwards with acceleration g/4 as in the question. And when displacement of the body becomes d downwards, you have to calculate that how much is the work done by the external agent, how much is the work done by the gravity, and how much is the net work done by the body. So first of all, I explained you that when the examiner says that body is being pulled upwards by means of force is being applied upwards, but body is going down, how it can happen. Let's mark the forces acting on the body. mg is downwards, and by means of a string, we are applying force F upwards. We are pulling the string with a force F upwards, and mg is acting downwards. Now, if body is accelerating downwards, it means mg must be greater than what? F. If body is accelerating downwards, the force mg must be what? Mg must be greater than F. Mg must be what? Greater than F. So you see here, net force is downwards. As I told you in the Newton's laws, net force is mg minus F, it is downwards. And the function of net force is what? To produce the acceleration. You know that in the Newton's law, what you learned, F equals to mass m into A. F is what? In the left hand side, net force. Its result is what? Mass into acceleration. So here net force is what? Mg minus F. Why I'm not writing F minus mg? Because I know that mg is bigger. Why body is accelerating downwards? Because mg is bigger. So net force is what? Mg minus F. That equals to mass m into A. So mg minus F equals what? M into A. A is what? G by 4. The acceleration of the body is what? G by 4 downwards. So it is G by 4. So F becomes mg minus mg by 4. That is what? 3 by 4 mg. So though examiner had not given you that what is the force being applied upwards, then they had only told you that body is accelerating downwards with G by 4. The force applied is such. The force that we are applying is such that body is accelerating downwards with acceleration what? G by 4. But now see, you got to know, you calculated that how much force is being exerted by the acceleration? 3 by 4 mg. Force exerted is what? 3 by 4 mg. Now we calculate all the three parts because we got to know the force. Like because see, we had to calculate that work done by external agent. Unless we know what is the force exerted by the external agent, how can we calculate the work? So now see, the answer of the first part W1 is what? How much is the force? 3 by 4 mg. How much is the displacement? So that was given in the question. Displacement is what? D downwards. It is what? D downwards. So force into displacement. What is the angle between the force and displacement? Force is upwards, displacement is downwards. So the angle between them is what? 180. So that becomes what? Cos of 180. Cos of 180 is what? Minus 1. So it becomes minus of 3 by 4 mgd. This is the work done by the force. So work done is what? Work done W1 becomes equal to what? It becomes minus of 3 by 4 mgd. Is that clear? Work done is what? Minus of 3 by 4 mgd. This is the work done. Let me check the audio. Audio check. Becomes equal to what? It becomes minus of 3 by 4 mgd. Yes. Is that clear? Work done is what? Audio. Okay. So now see. Now second becomes work done by the gravity. How much is the force of gravity? mg. In which direction? Downwards. Displacement is what? D. So force is downwards mg. D is also downwards. Angle between them is what? 0. So cos of 0, and that becomes what? It becomes mgd, because the value of cos 0 is what? 1. There's a work done by the gravity. Now see the third. The third point is what? W3, net work done. Because there are only two forces acting on the body, so we calculated the work done by both the forces. So W net work done will be W1 plus W2, sum of the work done by the two forces. So that becomes what? Minus 3 by 4 mgd plus mgd. You'll solve and get 1 by 4 mgd. This is the answer. There's what? W becomes equal to 1 by 4 mgd. This is the answer. This is the work done. Is that clear? So you get to know that what is the work done, how to calculate that. Means what? If in some cases, what will they do? They won't give you the force by which you have to calculate the work done. They'll describe some mechanical situation. Like here also, they describe it what? They describe that the body is being pulled upward with some force, but it is going downwards with acceleration g by 4. So you did not know, they did not give you the value of the force exerted by the external agent. What you did, you calculated by that mechanical situation that how much is the force exerted by the external agent. When you calculated the force, then you calculated the work done, then you calculated the work done by the gravity also, then you calculated the net work done. Is that clear? Now see. So this is how do we calculate the work. Now see, this was the calculation of work when one or more than one forces are acting on the body. Now you'll see, now you see, now look at this. Next is the calculation of work graphically. Calculation of work graphically. So how do you calculate work done graphically? You have been given a graph between force and displacement. There's a graph between force and displacement. The concept is what? Concept is area between the graph, and displacement axis. Displacement axis is a measurement of work. Is that clear? So means what? Suppose this is the graph. Just say 10. This is all in meters. Displacement is in meters. This is in meters. Force is in newtons. So you see, this becomes what? This 10 meter, this 20 meter, this 30 meter, this 40 meter. And here we have 20 newtons, this 40 newtons, 60 newtons, this 80 newtons. This is the graph. Graph is this. Now suppose the question is that calculate work done till displacement is, calculate work done till displacement is how much? It's 40 meters. So what you have to do? You have to calculate the area between the graph and the displacement axis, means this complete area you have to calculate. Is that clear? So how much will be the work done W? It is a right angle triangle. Area of the right angle triangle is what? Half into base into height. How much is the base? 40. How much is the height? 80 newtons, because this is the axis of force. So this length will be equal to how much? 80 newton. You have to take the reading from here. In terms of force, the length of this branch will be what? Height will be 80 newtons. So this is the work done, so much of joules. That means it becomes 40 into 40. So that is 1600 joules. This is the amount of work done. So hopefully you must have understood that what you have to do. You have to calculate the area between that point. Suppose here in this case, because the total work done was asked, the total work done that was done here from 0 meter up to 40 meter was asked to be calculated. Suppose they would have asked what? In the same figure. Suppose they have asked you to calculate the work done for what? Work done for the, from the, you see, work done from the 10 meter up to 30 meter. They say what? Calculate work done by the force from, work done from x equals to 10 meter to x equals to 30 meter. Calculate work done by the force from x equals to 10 meter to x equals to what? 30 meters. Then see how do you calculate that? You see what is the area between the graph and x equals to 10 meter to 30 meter. So what is this area? This complete area. So this is the area of the trapezium. What the figure is made, this area is what? Is the area of trapezium. Either you calculate the area of the trapezium, or you calculate what? Or you can calculate the area of one rectangle and one right angle triangle. Area of one rectangle plus area of one right angle triangle. So work done becomes what? Area of this rectangle. You see, area of this rectangle becomes what? Area of this rectangle becomes, this length is what? 30 minus 10. 30 minus 10. Just 30 meter, this 10 meter. So this length is what? 30 minus 10. How much is this length? It's 20. So into what? 20. Plus area of this right angle. So area of the right angle becomes half into what? This length. So this length is what? 30 minus 10. That is what? 10. Into height is what? Height is this much. So this height is what? 60 minus 20. This point is what? 60. This point is what? 20. So how much is this length? 60 minus 20. So that is what? It's 40. This will be the total work done in joules. Is that clear? So the point is what? Key from which point of displacement, from which point of position up to what point of position they have asked you to calculate the work done. You'll consider only that area. They asked you to calculate work done for a displacement from 10 meter up to 30 meter. So you had to calculate only this much of area between the graph and the displacement axis. So it will be only this much of area. Is that clear? This point is clear now? Now see. Now you'll see this. Suppose the graph is a closed path. Closed path means what? The point from where we start, we end at that point only. There's a force, there's a displacement. And the graph is like this, see. We start from the point A, B, C, D, means this is the graph, A, B, C, D. Right, this is the graph. And it's given here, it's 20, this is say 30, this say 40. This is in newtons. This is what? Force is in newtons. And here we have displacement in meters. This say 20, say this is 50, say this is 80. This 20, this 50, this 80, and this what? It is in meters. Now see, you have to calculate the work done. So the very first thing that may come into your mind is what? Displacement is 0, as because from what point we are starting, we are reaching at the end at that point. So work done becomes what? 0. But it's not 0. Actually, this graph is depicting what? It is not depicting the motion of the body. It's not that we are carrying the body along this path. It is not. The graph is depicting what? Like suppose say, you see, you have a displacement time graph. Displacement time graph for a 1D motion, that means motion on a straight line. Displacement time graph for what? Motion on a straight line. Say the graph is like this. So that does not mean that body is going like this and going like this. Because this is what? It's a straight line motion graph. With the passage of time, only one coordinate is changing, that is what? X. The displacement is only along X direction. So this is how the displacement is changing with time t. It does not mean that body is going along this direction or body is going along this direction. This is a graph for the straight line motion. So similarly, it is not that how the body is being moved. The graph is only telling you what? It is telling you that when position was 20 meter, the force of 40 Newton was applied, and that force continued to act on the body till displacement of the body becomes what? 80 meters. Then the displacement remains 80 meter. Now the body does not move. It was 80 meter here. Again it is 80 meter here. That means what? In this period what we did? We only reduced the amount of force. We reduce the force, and now force becomes how much? It becomes 20 meter. Now force becomes 20 meter, and displacement of the body with the force of 20 meter, now the body is carried up to what? 20 meter. So that means it is only describing how the force was when displacement was taking place. It's not that body is going along a cyclic path. The graph of the variation of force, the graph of the variation of the force with the displacement was represented in a cyclic graph in a closed path. So this was only the variation of the force with the displacement. It was not the actual motion. Now see, but the concept is what? What you remember? The concept is that when the path is closed, means from where we started the graph, we end at the same point, in that case the concept is that area of the closed path equals to work done. So what you have to calculate, area of the closed path means this area. So how much is this area? Its length is what? It is 80 minus 20. 80 minus 20. And how much is the breadth? It becomes 40 minus 20. 40 minus 20. So that becomes 80 minus 20 means 60 multiplied by what? 20. So that becomes, it is 1200 joules. This is the work done. It is this much is the work done. Is that clear? Now see, let me tell you one more concept. The concept is what? Suppose you have graph between the force and the displacement, and the graph is what? Graph is not a rectangle whose area you calculated very easily. Graph is a circle. And say this 10 meter corresponding to center, it is say 30 meter, and corresponding to this point it is what? Say 50 meter. Here we have 20 newtons, corresponding to center we have say it's 60 newtons, and here we have say 100 newtons. Here we have what? 100 newtons. We start from the point A, go to the point B, then C, then D. This is the graph. This is how the graph varies. We start the graph from A and get back to the point A. How much is the work done? Now see what you know. You know to calculate the area of the circle. And area of the circle is what? According to the concept that I told you, area of the graph is the work done. So area of the circle will be what? That will be the work done. So W work becomes equal to, you will say pi r square. Area of the circle is what? It's pi r square. But look at this. If I take radius from this side, it is how much? 20 units. This is the radius. So it is what? 30 minus 10, that is what? 20. Or this is also 20. 50 minus 30 is what? 20. But if you see, you take the radius from this side. This radius is how much? 60 minus 20. This is what? 40. Is that clear? So that means what? If we take the radius from the force side, it is what? It comes to be 40. If we take the radius from the displacement side, that comes to be equal to what? 20. So the work done W will be equal to what? Work done W becomes equal to pi R1 into R2, not pi R square. Take one radius from the displacement side, take the other radius from the force side, so that will be pi. Radius from the displacement side is what? 30 minus 20, that is what? 20. Radius from the force side is what? 20 minus 60, that is what? 40. So this much of joules is the work done. So many joules is the work done. This is the work done you'll calculate from here. So you must have understood that when it's a symmetric path like this, see. Even the same thing is true. When you find that the shape of the graph is what? Exactly square, you have to calculate the work done. So what will you do? Not square of one side. Take one side from the displacement axis. Take one side from the force axis. Multiplication of the two will be the work done. Is that clear? Now see. Now one more thing is there. It is this. Suppose the graph is, this is the displacement, this is the force. Means force is not on the y-axis. The concept was what? And the graph is not a closed path. Graph is like this, see. You have to calculate work done from point A to point B. Up to this point, how much is the work done? So remember the basic concept that I told you. The basic concept that I told you is what? Area between the graph and the displacement axis. Not that area between the graph and the x-axis, not that. Area between the graph and the displacement axis. Now because examiner have taken the displacement axis on this side, so this much of area will be the work. You'll calculate this area. Is that clear? So remember the basic thing, that when it is an open path, it's not a closed path. In the closed path, it's all like that to take the area of the closed path. Not when it's an open path, how much will be the work done? You have to calculate the area between the graph and the displacement axis. If displacement axis is in this side then this area will be the work. This area will be what? This area will be the work done. Is that clear? I hope this must have got clear. Now see. So this was the calculation of work. Now see, I define the power. So power is what? See, power, the basic definition of power is what? It is the rate of doing work. It is what? Rate of doing work. So when we say rate of doing work means what? It is the work done in unit time. It is what? Work done in unit time is the rate of doing work. Is that clear? Rate of doing work. So that is what? It is the work done in unit time. This is clear. But see, you need to know that there are two kind of powers that will be used in terms and will be asked in questions. One is the average power. Average power. And the other is what? It is the instantaneous power. Instantaneous power. One is the average power and the other is what? Other is the instantaneous power. So what is the average power? How do you calculate the average power? Average power will be the total work done, W, in the time interval in which this work is done. The time interval in which this work is done. Is that clear? Means what? A time interval will be given to you. You will calculate that how much work is being done in that time interval. You will calculate what? How much work is being done in that time interval. And you will divide that work done from the time itself. So you will get what? You will get the average power. But see, there is one term, instantaneous power. Instantaneous power by definition is what? By definition is that at any point of time, if you do a very small work called dW, when the work is very small, we call that what? dW. And this work is done in a very small point of time at any moment. That time interval is what? dt. dt is a very, very small interval of time. Then there is an instantaneous power because see, at this level of 9th class, you cannot exactly understand that what is the meaning of dW, what is the meaning of dt. So this formula eventually can be written in what form? It can be written in the form force into velocity into cos of theta. This equals what? Force into velocity into cos of theta, where F is the force acting on the body. The power is always generated by what? Force. Who generates the power? Force generates the power. Why force generates the power? If I ask you, who does the work? Force does the work. When force is applied and displacement takes place, then only the work is done. So because force does the work, so that means what? Force generates the power, because power is what? Rate of doing work. If work would have been done, then only we will say yes, power is being generated. And work will be done only when the force will be applied. So what generates the power? The force generates the power. So that force whose power generated is to be calculated. So once again, I would like to tell you that at a time on the body, several forces might be acting. So you have to see if they have asked you to calculate the instantaneous power. They have asked you to calculate what? Instantaneous power. Then you'll have to see that they have asked you to calculate the power of which force. So take that force into what? Velocity, because velocity of the body, it cannot be velocity at a time. Body can have velocity in different directions, or body can have number of velocities. At a point of time, velocity of the body will have one value. At a different point of time, it will have a different value. So at the moment when power is to be calculated, at that instant, that is why it is the instantaneous power. Multiply it with the velocity of the body, and theta is what? Theta is the, here, theta is the angle between the force and velocity. theta is the angle between the force and the velocity. So theta hai, that is what it is, the angle between the force and the velocity. So it will be force into velocity into what, cos of theta. This is the power generated by the force F if you have to calculate the instantaneous power. But in the 9th class, you need not to focus much upon the instantaneous power, though I'll be giving you some examples. Your main focus will be what? It should be how to calculate the average power. This will be what? How to calculate the average power. So I tell you how to calculate the average power. Look at this. I give you one example. In this example, though I'll tell you even to calculate the instantaneous power also, look at the example, it's very simple. Suppose we have a block of mass 2 kg, and this block is lying on a smooth horizontal floor. This block is lying on a smooth horizontal floor, and here we apply a force F. F is, it's 20 newtons. There's what, 20 newtons. So you apply a force 20 newtons, and what you have been asked, this is a smooth floor, there is no friction. Calculate average power generated by the force in interval of 5 seconds. Interval of 5 seconds. How much average power will be generated by the force in 5 seconds? 5 seconds. And also, what is the instantaneous power being generated by the force at t equals to 5 seconds. Instantaneous power being generated by the force at t equals to 5 seconds. You'll see this. You'll look at this. So, because see, the only one force is acting on the body, obviously mg is acting downwards, reaction n is acting upwards, but because body is not going upwards or downwards, so these two forces are being balanced. In the direction of acceleration, how much is the force? 20. So 20 equals to mass m into a, that means a equals what? 10 meter per second square. So body will move in this direction, the direction in which force is being applied, with a force of acceleration of what? 10 meter per second square. So how much will be the displacement of the body s? That will be ut plus half at square. So you see, s equals to u is 0 because there is no initial velocity of the body. If there had been some initial velocity, examiner would have given it to you. But there is no initial velocity, so there is what? Ut plus half at square, u is 0, so there is half a. How much is the a? 10. How much is the time? 5 seconds. So square is what? 25. So this becomes 125 meters. There's what? 25 into 5, that is what? 125 meter is the displacement. So work done W in time 5 seconds is what? Force into displacement into cos of 0. Because here displacement is in the direction of force, so the angle between them is 0. Cos 0 is what? 1. So that becomes force is how much? 20. Displacement is 125. Cos 0 is 1. So this is the work done. And this work is being done in what time? 5 seconds. So how much is the power P? W by T. That is what? 20 into 125 divided by what? 5. So that becomes 25, and that becomes how much? It becomes 500 watts. Unit of power is what? Watt. Unit of power is watt. It is the MKS unit. It's what? MKS unit is what? Watt. But watt is relatively very small unit, so we use the bigger unit, kilowatt. Kilowatt. And kilowatt is what? 1 kilowatt equals to 10 to the power 3 watts. Similarly, there's one more unit, British horsepower, BHP. 1 bhp equals what? 748 watts. This is something that has been taken as standard. 1 British horsepower equals what? 748 watts. So you have to remember it. So this, how do we calculate the average power? Means the calculation is very simple. The time interval in which you have to calculate the average power, just calculate that how much is the work done in that time interval, then divide it by that time interval only. Divide by that time interval, you'll get the average power generated in that interval. Is that clear? You understand that how you have to calculate this? Now see the instantaneous power. Now see here, the instantaneous power will be what? I tell you that also. Instantaneous power, you see, instantaneous power being generated by the force at time t equals to 5 seconds. What you need to calculate is, calculate what is the velocity at t equals to t 5 seconds. So v equals to u is 0. A is what? A is 10. T is what? 5. So that is what? 50. It is 50 meter per second. Velocity is what? 50 meter per second. Now see, the power instantaneous becomes F into V into cos of angle between them. So force F is what? 20. Velocity is 50. Angle is what? 0. So cos of 0. You see the direction in which you have applied the force. Obviously the body will gain the velocity in that direction only. So that is what? Cos 0. That becomes 1000 joules. It is what? It is a 1000 joules. So this is the, it is the power 1000 watts. So 1000 watts, that means 1 kilowatt power is being generated. 1 kilowatt power is being generated by the force. This is how to calculate the instantaneous power also. Did you understood this? So the calculation is generally simple, and it is what? It depends upon that how much can you use the Newton's law. How much do you know the kinematics, that is straight line motion? Because see, from the Newton's law here you calculated how much is the acceleration. Through that acceleration you calculated how much is the displacement. By using the equations of motion, you calculated how much will be the velocity. Then you applied that displacement, velocity, whatever is needed in the definition. Like you calculated work done upon time interval, that becomes the average power. And if you want to calculate the instantaneous power at any instant, calculate that what is the velocity at that instant. So force into velocity at that instant into angle between cos of angle between the force and velocity, which is 0 here. So it becomes force into velocity into what? Cos of 0. Cos of 0 is what? 1. So you got the answer. Is that clear? This point is very clear. Now see. Now you'll see this. So this was the definition of the instantaneous power, right? Now see, in power itself, we move a little ahead. Now see, this is an example. Suppose there is a block of mass m. You try to understand that very well. There is a block of mass m. And the statement is what? The coefficient of friction, the floor is rough. The coefficient of friction between the block and the ground is mu. Coefficient of friction between the block and the ground is what? Mu. And the question is that calculate the power needed to pull the block with a constant speed v. No force is given, neither the time interval is given. So one thing, first of all, because in the question time interval is not given, so you can very well understand that there's a question of instantaneous power. If time interval is given for a task, then the work done can be calculated in that time, and work done can be divided by that time to get the average power. But the task is given, no time interval is given, you'll understand that the question is what? Instantaneous power. But when you understand the question is of instantaneous power, you immediately search for what? Force. But no force is given here, only the task is given. So let's find that to fulfill that task, how much force we need to apply. You see, mg is downwards, direction n is upwards. When we try to carry the block along this direction, the force of friction will be acting in what? Opposite direction. How much? mu into n. Because we know that n is equal to mg, so the force of friction will be equal to what? It will be equal to mu into mg. There is a force of friction acting in the backward direction. And we are carrying the block along this direction with a velocity v. So how much force we will have to apply? Only that much force, that much is the friction. So that is what? Mu mg. Now see here, you may ask me, sir, if force of friction is mu mg and you are applying the force mu mg in the forward direction, then how body will move? Body will move. Newton's law is not that without force body cannot move. Body can move with a constant speed. The magnitude of velocity will not change, because to change the magnitude of velocity you need the force, because that is what? Acceleration. Force does what? Force produces the acceleration. But the question says that what? It has to be carried with a constant velocity. So just apply that much of force which can overcome the force of friction. Force of friction is what? Mu mg. So we need to apply how much force? We need to apply exactly mu mg force, so that this force of friction can be what? This force can be overcome. So we are applying the force mu mg. So power P becomes what? It becomes force that we applied. In what direction did we apply the force? We applied the force in this direction. We applied the force in this direction. Is that clear? And in this direction is the velocity v. So mu mg into v into cos of 0. So that is what? For power P equals to mu mg v. This is the power that is needed here. Is that clear? So this is the, I give you one more example of the power, and I just end my session, today's session here. In my next class, I'll continue with the power and energy. All right. So have a good day.